The value of water on farms can't be underestimated, but across Australia, too often there just isn't enough. While technology has transformed agriculture, the way we search for underground water can be pretty old-fashioned. But Landline's Courtney Wilson has found a company that could change all that.
Drilling for water in a region named the Granite Belt is as tough as it sounds.
We've had a rig down the Granite Belt for a few months now, and it's all very hard drilling. It's a basalt granite combination, and it's slow, it's time consuming, and it's hard work.
That's why farmers in this region traditionally rely heavily on above ground water storage for irrigation. But a dam is only as reliable as the rain that fills it, and recent crippling drought has left many farmers exposed.
You think to yourself, I've got 2 years' worth of water plus a bit for evaporation. I will get a rainfall runoff event every 2 years. This drought has probably realigned our expectations or our thinking around what is and is not a reliable amount of water to store.
That sentiment is shared by many. Fruit and vegetable growers, winemakers, livestock producers, even the local council have all had to grapple with finding a way forward in the midst of a severe water shortage. As it stands, the local council and state government are continuing to spend $800,000 a month to truck water in to the nearby town of Stanthorpe. But could there be a way to hone in on where good, reliable underground water is just waiting to be found and tapped into? It involves drilling far deeper than usual, using a number of different technologies to guide where to drill and to what depth.
Round numbers, the prediction is 20,000 litres an hour at 200 metres, which is roughly twice as deep as we've ever gone before. But if it proves up right, it'll be a tenfold increase on the current flow rate of our bores.
It's a big, risky and expensive gamble. But the potential payoff is also huge.
Based on what you've seen so far with the drilling, how are you feeling?
Bloody nervous.
Drought-proofing Rosemary Hill would be no mean feat. The orchard stretches across 25 hectares and at capacity houses 30,000 fruit trees. There is some underground water in use here, but it's marginal at best. One small bore which produces around 2,000 litres an hour.
When that's pumped day and night, you can accumulate a body of water to at least keep trees alive, but it's an expensive exercise to pump a megalitre that way, and it's also slow.
Until now, it's been the farm's best option, and not for a lack of looking for others.
Back in the last drought, only 5 years ago, 2013-14, drilled 7 wells then, and ultimately only one of them has proven to be, I guess, commercial or industrial, giving us water at a level that we can really meaningfully use.
Technology has drastically changed the way farms operate in so many ways over the past few decades. But when it comes to looking for underground water, for the most part, it remains rather old-fashioned.
The guys who do divine, they use timbers. Some guys use wire, willow or pepperina, and they'll walk around and they'll find a stream, and they'll try and what they believe is a couple of streams. They'll try and cross them over and find the most likely point for water. And look, there's different levels of it. People have different ideas of how it works, and it's what we've been using forever.
But standing the test of time hasn't always resulted in reliability.
Searching for underground water is, by its very nature, hit and miss. It's not uncommon for farmers to tell you they've spent close to 6 figures and still walked away empty-handed. That's why a breakthrough in the method used to find reliable water could be so meaningful for so many.
We have a change of vegetation happening along that line.
Yep.
Essentially, because of the hard rock this region is synonymous for, most underground bores around the granite belt barely scratch the surface.
Most people in the area would drill until they hit the granite, and they're just catching water that's soaked through precipitation over the years. What we're looking for is the cracks and fractures and fissures in the rock system where water's coming up. So we'll go through the granite into those fractures.
The mapping used to look for those possible fractures, which could indicate deep water pockets below, is used around the world for different applications. In the developing world, it's mostly applied in humanitarian work and commercially by mining companies.
We're looking at magnetics and gravity and radiometrics and lots of different indicators. So we know, rather than having to work with a whole property, we might zone in to 2 or 3 prime locations that have all the indicators of good water supply.
We're trying to sort of get an image of what's happening layer by layer if you could look into the earth. And the more we can get these specific things to line up, you know, the more we can kind of eliminate some of the risk going down.
Yeah, right. And how...
Volunteers from the Lawrence Anthony Earth Organisation have been involved in the process. The group is an international not-for-profit that works to find and vet scientific solutions for global environmental challenges.
So what could this sort of fracturing mean?
Ideally, the situation is that this is a surface expression of what's occurring deeper.
What follows the mapping analysis is something called ground truthing.
There's lots of natural indicators of water availability. You see indicators in the rocks and the geology, but also the trees and the plant life and even the insect life.
So based on the lineaments, here's the spot.
Okay.
Gamma and passive seismic devices are put to use.
0.9.
The team detect and log natural low-frequency earth movements, which again are indicative of underground deposits of some kind.
We want the bookends of science with the mapping and the seismic detection, but everything in between. If we can take layers of risk off to get to certainty when we put the drill in the ground, it's much better than just randomly picking a spot.
For farmers with finances that have already been stretched to breaking point by drought, there's a lot riding on a risk like drilling another bore.
There's a significant cost in drilling, and so we have to charge. Unfortunately, we have to charge to drill and have a look. And unfortunately, if it's a miss, it's a geological experiment. It's of no use to the farmer.
We chose Stanthorpe to come and prove up this technology and show what we can do, help Stanthorpe in the same process, and then roll it out into other towns that need help. There's been huge investment both from the international companies that we've brought in as well as locally, and doing the drilling's not a cheap exercise. So we've got enough confidence from the science to do that, and we're prepared to back ourselves.
So now for the big question, did it work? Well, like most big ideas, there have definitely been some hurdles along the way.
So we're finally back, Angus. It's been a few hard months, but this is it.
It has taken a little while to develop this bore up to the moment of truth where we're ready to turn it on and start pumping water.
So the moment of truth, as you said, you want to flick the switch?
You do the honours.
Thank you. And that is a pretty good sight.
It is, and normally that'll be plumbed into that bit of pipe there, which will run down to the dam, ready for us to irrigate our trees with.
Instead of days or weeks, it took months to get here, thanks to numerous challenges, not to mention the impact of a global pandemic. Regardless, those involved say this is proof the technology works.
So they've drilled to about 220 metres on a prediction of 3 litres a second. We're currently getting about 1 litre a second. The reasoning for that is the pressure required to drill such hard rock forced a lot of the rock fragments into the fracture, and we believe that's blocking the flow up a little bit. The advice we've got is that it may take some months for this bore to develop up to its full potential. So we're going to need to continue to be patient.
Even at the reduced flow rate, reliable underground water means a great deal for this farm.
As we stand here in mid-July, our orchard has not received anywhere near enough rain to break the drought, so to speak, and a litre a second is very valuable. We can do a lot with that and plan to in the coming season.
Many farmers drill and hope and spend too much money on dry holes. We wanted to bring technology in to provide an insurance policy that when they do spend that money, they've got a much higher chance of finding water.
He's hoping local governments will also take heed and consider investing in these new technologies, especially in regions like this one, where water security is an ongoing struggle.
You know, the $800,000 a month they're using to truck water from a nearly empty dam to an empty dam could solve their town water issue.